you. Hi, I'm Daniel Ehrenberg, or they say in Spain, Daniel Ehrenberg, uh, where, and I came to talk about decorators. This is a kind of subtle topic, so I was having some cold feet preparing for this, and I think actually changed the agenda to talking about class fields and private methods. But let's talk about decorators. So yeah, I'm Daniel. I live outside of Barcelona, work for Igalia, and mostly I work on TC39, also on the WebAssembly community group and some other standards efforts. So what's TC39? So you remember ES6, or some people call it ES 2015? That's the new version of JavaScript that came out in 2015 that includes features like destructuring. If you want to swap two variables, you can just say yx equals xy with both of them as arrays. You can assign to an array, and it destructures it, and so it swaps the variables. And that was brought to you by TC39. So TC39 is a committee of ECMA that has a whole bunch of different kinds of members. They're JavaScript developers, implementers, like people who work on VMs, such as GraalVM. I hope to see them in TC39 soon, but also the people who work on browsers and Node, people who work on frameworks and libraries, and academics and specialists in programming languages. And what we do is we work on this document. This is the ECMA 262 standard, the ECMAScript language specification. It's called ECMAScript because JavaScript is a trademark of Oracle, and so, well, Oracle and Mozilla, it's kind of complicated. Anyway, ECMAScript is neutral. Didn't mean to be picking on Oracle. I'm impressed by the last talk. Anyway, so we work on the ECMA 262 standard. That's just the 262nd specification made from ECMA, this standards body based in Geneva. And we develop it on GitHub, like other open source projects, with issues and pull requests. But we also have meetings. Every 2 months, we get together in person for 3 days and talk about the things on GitHub. And we also talk about proposals, which advance through a stage process. When I was living in the US, I would go to all the meetings physically. Now that I live in Europe, I call into a bunch of them, and it all works out. So proposals move through this stage process. Stage 1 means we have an idea that we're discussing. So when you hear this thing advanced to stage 1, that means TC39 has started an open discussion involving the committee and the community about a particular idea. It doesn't mean we're definitely going to do it. At stage 2, we decide we're going to do this feature, and we have a first draft that we're pretty happy about the direction of. But there's still more to work out. Stage 3 means we have this really detailed final draft. It's been broadly reviewed, and it's ready to go. We're ready to, many things ship in browsers and Node when they're at stage 3. And what stage 4 means is we have multiple implementations. We have conformance tests, like shared tests between all the JavaScript implementations that ensure that the feature works as expected. And so we're ready to say that it's a standard. So might be wondering what's going on in TC39. So there's decorators, but there's also a lot of other features. For example, BigInt. So I want to go through some of the things that happened at the recent TC39 meeting in early June in Berlin. So BigInt advanced to stage 4. So in JavaScript we have numbers. Numbers are double precision floating point binary. And so what that means is when you get past a certain size, it just stops acting like an integer. It just rounds back to the same thing. If you add 1 to this huge number, you get that same number back. That's not nice. But if you add an n at the end so that you're using big ints instead of numbers, then it actually increments properly, and we get 3. I don't know if you can see that very well. And n stands for big int. See, it's the 5th letter of big int. Anyway, We also got dynamic import to stage 4. Dynamic import, with ES modules, you import with an import statement. So that's sort of like a static import. And dynamic import lets you import as an expression. It returns a promise, and you can use that promise that tells you whether it loaded successfully. The reason that it's a promise instead of just going synchronously like require is because it may need to do some like network fetching or file reading, and it's better if those can run in the background while other things run in parallel. So yeah, thanks Axel Rashmeyer for the example. So we also had weakgraphs. This is a really long time feature request from JavaScript developers that you'd be able to get a little bit more interaction with the garbage collector. So you can make a reference to an object which doesn't hold the object alive. That's a weak reference, and you have this deref method to get at the inner object. There's also a mechanism for calling finalizers. So to step back a little bit, BigInt and dynamic import got to stage 4 in recognition of how they were already broadly implemented and starting to ship all over the place. So we said this is standard. For weakgraphs, we really finalized the design. We went through a lot of iteration. They've been under discussion for many years, probably more than 10 years. But over the past two years or so, we've really gotten consensus from implementers that they want to do it. And we've refined the design a lot. We've gone through a lot of different iterations to make sure that it would be both friendly to users and respectful of the sort of invariants and properties that you expect from weakgraphs. And so we decided that weakgraphs are stable enough for that, and that we're comfortable to see this draft sort of shipping in browsers and in Node, which I expect to happen pretty soon. Like on the order of, I can't speak for them, but there's already a draft in V8 that's behind a flag, so I think we're well on our way. We also talked about optional chaining. So this question mark dot operator, I gave it. If you want to learn more about this, I gave a talk about it in Brazil JS last year. But just here's a slide from Justin Ridgewell where he was presenting it to the committee. This makes it so that you can access a property on an object, even if that object might be null or undefined, then it falls back to undefined. So this is really popular in other programming languages like Swift and CoffeeScript, and it's also popular in JavaScript libraries like low-get or IDX. And so I think it's a really great addition to the language. And we had been debating optional chaining for years about what's the right way to do it. And we finally have this first draft that the committee was able to come to consensus that this seems like a viable way to go. So very, very happy about that work from Justin and Daniel Rosenwasser and Gabriel Eisenberg and Dustin, can't remember his last name. So pipeline operator, this is under detailed investigation with empirical data with an effort led by Yulia Startsev. So the pipeline operator, say you have some functions that take an argument and they return something. Well, you could combine them using nested function calls, but this is actually kind of ugly, and a lot of people construct libraries that are written to use method chaining. But that's not so nice because you can't import methods from a module. So it is kind of nicer to have functions. But now this function chain goes backwards logically. Wouldn't it be nice if you could just use a pipeline operator and everything points forward? So we have this hello, and then we pass it to a function and pass it to another function. So we saw a great presentation about detailed survey work to push the pipeline operator forward. So now I want to talk about a big long-running effort that we've had in TC39 that pulls together a bunch of different work, which is class features. So this presentation is about decorators, but step back, we want to talk a little bit about classes. Not sure if you're familiar with HTML custom elements, but they're sort of like a framework that's built into the browsers, or the basis for a framework. What you could do is extend HTML element and give it some functionality. and then register it so that when you see that element in a document, it just magically works. It is that. So in this example, when we have this little instance variable underscore x that holds our counter, and this forms a sort of button that you can click, and then it will increment that number. So classes in ES6 were deliberately minimal. They don't really let you do very much. There's no way that you declare your properties. There's no notion of privacy, and it's also not extensible. There's just this class definition, and there's no way to like tie extra functionality into it. Basically, all you can do is define methods and the constructor, and static methods and accessors. So the first thing that we're considering doing in TC39 is adding public field declarations. So instead of just initializing x to 0 here in the constructor, we can initialize it with a declaration in the class that's sort of pulled out above it. And this lets you see really clearly what the structure is. The pattern is declare the fields that you're going to use. And this actually sometimes could make it easier for the engine to track what's going on in the code. You might have heard talks from people on the V8 team about monomorphic code patterns, where you really want to add all of the properties to the object soon after you create it, so that code that's using that object has a consistent shape. If you declare all your properties, then you're probably going to get closer to that good path. And next, we added private. So this hash, instead of an underscore, this makes it so that you really can't access those things outside of the class. So with custom elements, with web components, there was a big push towards this thing called Shadow DOM, where you can encapsulate the internals of an element CSS-wise, so that the styles don't sort of permeate through, so that you can make your own element that has its own, way of looking. And private fields and methods do the same thing for JavaScript. It lets us really encapsulate JavaScript so that you don't have to worry about who's messing around with the internals of your class. This is important if you're developing a widely used library, so that you can upgrade it over time. So the slogan is hash is the new underscore. If you want strong encapsulation, not everybody needs strong encapsulation, but when you do want it, hash is there. So, with an underscore, you can just read it outside the class. But if you use private fields, it's a syntax error. There's no way to get at it unless you sort of do something special to expose it to the outside, like pass in a callback. And this is also at stage 3. This proposal's been at stage 3 for, I think, a couple of years at this point. And now starting to ship in Chrome and being implemented in JSC and SpiderMonkey, in Safari and Firefox as well. So anyway, this talk was supposed to be about decorators. What are decorators? So coming back to this example, there's some bits of code that are kind of repetitive. Like it would be kind of nice if instead of writing this define call at the bottom, we could sort of declare at the top of the class that it's an element with the name. Or there's also we have to do this .bind thing every time we call it. It would be nice if these methods could just be declared bound, and you didn't have to call that every time. Another thing is when we have this hash x, there's you have to you have to remember to call the re-render function when hash x is there. There's no way to sort of tie into it and just make that an observed property. And so decorators give us ways to hook into the functionality of classes to do these kinds of things. They let us, with this @define element, we could just say, well, this define element applies to the following class. With @observed, we could sort of watch a field declaration, and with @bound, we could turn a method into a bound method. So decorators are really popular in the JavaScript ecosystem. Many frameworks take advantage of them, and but not just frameworks. They can also be used for logging. And when I mention that I work on TC39, to people, a frequent response, well, many people ask about optional chaining or pipeline or types, but many people ask about decorators. It's something that people are using. It's pretty annoying to have to set the particular build flags, and there's some inconsistency in how those work in the ecosystem right now. And so these TypeScript experimental decorators and these Babel legacy decorators are really popular, even though they don't represent any particular standard. And that's the state of the proposal as of 2014. So in around 2014, 2015, Yehuda Katz and Ron Builtin and some other people got together, and they said, look, classes don't give us enough functionality to be useful. So at that time, frameworks typically had these systems where you would pass in a big object to them to construct a class. There were all these different class frameworks, and a lot of them didn't work very well. And the hope with ESX classes was we can eventually make this work. So they did a great job aligning the ecosystem behind this early decorators proposal. But as we proceeded through standardization, they realized, and the committee realized, that there are certain changes that need to be made. So for the past 4 years, we've been working in TC39 on standardizing modified versions of this decorators proposal, though the developer community hasn't completely followed along. So anyway, to give some examples, in Salesforce, they have this, they want to use custom elements, but it can get kind of complicated when dealing with attributes and properties. But this complexity can be encapsulated in a decorator, which in their Lightning framework is this @API. Polymer also had a similar decorator. So you see patterns that repeat across different software projects where they need to accomplish the same thing, and decorators give them a mechanism to hook in and do that, or from mutations. So yeah, this also comes up in Ember, similar things. So yeah, I get the feeling that JavaScript developers are really excited about decorators, and we have a thread on the decorator repository and about what features people need, and a lot of people are asking for the features from the initial proposal, but there are some other things that that are desired, like better interaction with private and fields, and scheduling certain callbacks in certain places, which we're adding to newer proposals. And there's also a lot of demand for decorators on things like functions and variable declarations, which is interesting, and not part of the initial or current proposal. So some goals with how decorators should work in their standardized form is, one is that it should be fast, both in the transpiler implementation, in how Babel and TypeScript will make them work on current JavaScript environments, and also they should be fast when built into JavaScript engines. And they should be easy to use. They should be easy both to use the decorators that somebody else wrote, and it should also be easy to write your own decorators. And it's not clear whether the previous proposals that we've been working for years on met these goals. We heard various sources of resistance and hesitation, and so for that reason, since the beginning of this year, we've been working in TC39 on a new decorator proposal. So just to give some history of the decorators proposals, yeah, in 2014, 2015, there was these experimental decorators, and these work as functions. So after the @ sign, it's a function that gets called with this sort of descriptor, and then that can modify the descriptor, and that modifies the class. And then to meet some of these extra use cases, we switched in 2016, or was drafted in 2015, to descriptor-based decorators, where rather than just using property descriptors, there's more detailed descriptors for different elements or the classes, and this can express more things. And these descriptors got a bit complicated as we evolved them over time. A contributor made this big table to summarize it. I think, I thought the table was really clarifying, but it just scares a lot of people who see it. Wow, there's all this stuff to learn. Anyway, so the table approach had a lot of concerns raised about it from implementers, and the question from there was, why not go back to the original decorators? And the issue was that they're both too dynamic and also too limited. The original decorators proposal really rested on the original class field semantics, which were based on setting a property, but now it's like doing x.y equals z, but now it's more based on object.define property. So that made some of the functionality not quite work out. There's also integration with private fields and methods, where when you're all based on property descriptors and property keys, like strings, those don't really apply to private. So we need to rethink that a bit. It's also not clear how to extend them over time. When they're just functions that get called, we can't really change their calling convention without risking backwards compatibility. So makes it even less clear how to fix these problems. Yeah, and there's inconsistencies of Babel versus TypeScript, and they're both in heavy use. So yeah, it doesn't seem viable to standardize the original version of decorators or the version that we were proposing previously in committee. So yeah, in addition to those sort of implementation concerns, there are also kind of language level concerns with both of the first two versions, that for people writing decorators, you had to understand all these things about object.define property, yeah, and difficulty to extend over time. So the reason that these descriptor-based decorators were slower is because they, so there was an experiment done by LinkedIn where they tried deploying the sort of second version of decorators and found that it had a measurable slowdown in their application. In the Babel implementation, there's lots of code generated and lots of complexity to execute them, and it's really unclear how to eliminate that. And in browsers, there's the same kind of issue where the just-in-time compilers really, sometimes you're running in the JIT and sometimes you're running in bytecode. And when you're running in bytecode, fundamentally, that's still a static compilation, and you still kind of want that to be fast. What browsers have found is that so much of the code execution time is in startup, is in code that the JIT's not going to have a chance to optimize. And so it's not really a great idea to add new language features which make that slower. So it's nice if the engines, both for transpilers and native JS implementations, can see what's going on. And the truth is that decorators in practice do have certain predictable shape. So the new proposal is for built-in decorators. And the idea is that we have a few basic building blocks of decorators that are there that do something to change the structure of the class. And we have a way to compose them. But that these composed decorators are sort of more statically analyzable, because the engine can tell when it's generating the bytecode or when it's transpiling what the shape of the whole set of built-in decorators are. So there are 4 built-in decorators that are proposed, and there's this new syntax for composing decorators proposed, where you can declare a decorator as being the composition of several other decorators, and you can pass arguments to these. So for example, the @register decorator takes a function which is a callback that gets called when, so I want to show these in terms of what they boil down into. So we talk about desugaring in programming languages. So syntactic sugar is this idea about one syntax is a nicer form for another kind of syntax. So this @register decorator sort of registers a callback that gets called when the class is created. Or when you call it on a class, it just calls that callback on the whole class. And so, for example, for that define element example that was there in the beginning, we could define this. So remember, we could import this define element from a module. And when you import the decorators, you import them with an @ sign. So the @ is part of the name of the decorator in the new proposal, which matches how most people write documentation for decorators. People think about them as having the @ in the name. Anyway, this could be implemented with this decorator declaration format. It takes these arguments and it calls out to register, passing in a callback that gets calls. So in this way, it does the same thing of defining the element. Just for time, I'm going to skip the slides about wrapped, but this basically wraps a whole class or a method, and so you could implement a logged decorator. So for next steps, I want to recommend that for now, people just stick with their current version of decorators. We went and implemented, or Nicolo Ribaldo implemented the stage 2 decorators in Babel, and he did a great job of those, but it doesn't seem like that's going to be the way forward, given the feedback that we got from browsers and from this LinkedIn experience and from several different sources. It seems like we're going to have to do something different, but it's going to be experimental for a while. So there's ongoing work to implement this new proposal in Babel, and the goal is that for users of decorators, it should be a simple code mod to upgrade from one to the other. And for people who maintain decorator libraries, then we should be maintaining the functionality of the, more or less, of the original decorators that you might be using in Babel and TypeScript now. So like the @ sign when you're importing a decorator is new, but that's should be code moddable. And so our plan going forward to prototype this is we're going to write the specification, implement a draft of it in Babel, and we may over time add additional built-in decorators. And so the idea is to try out the new decorators, to get all of your help trying it out in your programs, especially ones that you're not going to need to maintain over time because the proposal is unstable, and collect feedback, and to propose it for stage 3 in TC39 once we have that feedback. So yeah, it'd be great to have your help driving this forward in the future. I have some slides about ways people can help, but also a little bit out of time, so I just want to say about all of this TC39 stuff, take it easy. Some people get the impression that they have to learn everything about what's going on here, and I think it's really great to have more developers and broader involvement in here, but also nobody knows everything here. Everybody has different pieces of knowledge, and we can all sort of work together and contribute, and we all have different specialties, and yeah, it's important to have a balance when contributing to these things or following these things, and not go too far. Anyway, decorators are in progress. They seems like they're going to be different from what people are using now, but hopefully in a good way. And it'll be great to have your help to move decorators in TC39 forward. So you know, Daniel Ehrenberg, Little Dan, and thanks for coming to the talk. What? Okay.
Thanks a lot, Dan. So, are there any questions on this topic? Yeah.
Hi. So a little question about private fields. I wonder why didn't we simply use like a private keyword or something like that?
Well, maybe I should have given the private fields presentation, but it's kind of complicated. It really just wouldn't work in a. You can do that in TypeScript because TypeScript has types for all the values. So the way that private works in traditional languages like Java or C++ is the type system is really involved in enforcing privacy. When you see an access to this.x, then the way it works is the type system checks, okay, what's the type of this? And then what is that property X? Is that a public or a private property? If you're outside of the class and you're referencing a private property, then you get a type error. In JavaScript, we can't do that. We leave the type system to be layered on top with systems like TypeScript or Flow. And we don't intend to learn about types. I mean, at least there's no active proposal in TC39 to do that. So we have to have a way to determine without that whether something is private or not. And the way that it's based on is sort of lexical scoping. And ultimately, we need a way that syntactically, at the site of accessing the private field or method, that we know whether we're calling it private or not. So fundamentally, when you see a private field or method declaration, that's sort of declaring a new inner name. And then anywhere in that inner scope, if you see the reference to that, it's referencing that particular name, which differs fundamentally from normal property access, which is based on strings that are just global. So.
Okay, any other questions?
Hey, I was just wondering, as a member of the TC39 team, do you ever feel like you have a thankless job in a way, and that everyone just comes to you demanding new features, keep working, or do you actually feel appreciated in the community?
I definitely feel appreciated. Okay. There's definitely a lot of complaints, but I feel like people overall, there's so much sort of being constructive here, and I feel like the people who are worried about if the feedback they give might be considered too divisive or something, those people should be giving feedback. There's this effect where people who would be more respectful and more constructive are like, oh no, I'm going to back away for the experts. And then the people who are the opposite are just very forward about it. So anyway, even in this environment, just encourage everyone to give feedback on these things. And you can do that in GitHub. I'm also organizing some calls to discuss things more, and let me know if you're interested in getting involved in those, and I'll be happy to talk to people in the break more about various ways to get involved in TC39, but there's just a lot of work to do, and I'd appreciate help, but also no pressure.
Any other question here?
Hello, is there an ETA for finalizing decorator draft, or is there a roadmap? As you can guess, I'm really eager to use that.
I mean, all I can give you is my hopes. I hoped that decorators would be at stage 3 6 months ago, or a year ago, and that didn't happen. I hope that this version of decorators could be at stage 3 in 6 months or a year, and we'll see what happens. I mean, ultimately, it's not. This isn't a train that's just going on a predictable path, because we have to build consensus among a lot of different stakeholders here, and it's just not even clear whether we will be able to come to a single technical solution that meets everyone's requirements. So I really hope that we will be. I hope that this will be the basis for it, but giving an ETA would imply that we've already reached that consensus, and we haven't.
Okay. Any other questions? One over here.
Hi. I heard a talk from Axel Rauschmeier where he basically talked about stuff that's missing in JavaScript. One of these things was comparing the values of objects. Is that something that's currently in discussion?
So I think Axel might have been talking about a way that you can have these deeply immutable value objects that could be cheap to compare. That could be cheap to compare by value, and that is under discussion. You can go to Robin Ricard has this proposal for records and tuples, which would be sort of we've been iterating on this idea, and so I'm looking forward to seeing that be discussed further. But comparing objects by identity is already cheap, but this one would have, when you compare the objects, if they're these deeply immutable value objects, or records or tuples, it's the current draft name, then you would be comparing them deeply by their value.
Okay. Any other question? So if something pops up, just go to Dan and ask him. He seems to be a nice guy.
Well, thank you.